Hello students, let us continue the session on arithmetic progression revision part. We had stopped at question 6 of higher order thinking skills. Now the question 7th, find the sum of all 2 digits odd positive numbers, and this question was asked in Kendriya Vidyalaya examination 2014. First we have to make the list of 2 digits odd positive numbers. The required arithmetic progression is 11, 13, and it continues, and the last 2 digit number which is odd is 99. In this question, in this sequence, the first term is 11, the common difference is 2, nth term is 99. We need to find the sum of these n terms. First we need to find out how many terms are there. For finding Sn, we require this n. How do we do that? We shall make use of an equal to a plus n minus 1 into d. An is the nth term, 99. The first term is being 11 plus n minus 1 into the common difference is 2. So on transposing 11, it becomes 88. On dividing by 2, we get the value of n minus 1. So n value will be 45. So there are 45 2-digit numbers. So sum of those 45 terms is 45 by 2, n by 2 multiplied to a plus an. We get it as 45 into the sum of 99 and 11 is 110 divided by 2. And we get it as 2475. Next question, question number 8. Find the sum of the 2-digit numbers divisible by 6. 2-digit number which is divisible by 6. The first number is 12. The next number is 18, and it continues till 96. It will be the last 2-digit number which is divisible by 6. So as we had done it earlier, we need to find sum of those n terms. For that we require n value. Here we have the first term as 12. The common difference is 6. Nth term is 96. Let us make use of a plus n minus 1 into d as an. A is 12 plus n minus 1 into the common difference 6, which is equal to 96. So n minus 1 into 6 will be 84. So n will be 84 by 6 is 14, added to 1, 15. So the sum of 15 terms is 15, will be 15 by 2 multiplied to the first term added to the nth term. So we get it as 15 by 2 multiplied to 108. So it is nothing but 15 multiplied to 54. We get the result as 810. So the sum of 2-digit numbers which are divisible by 6 will be 810. Next question. Question number 9. Find the sum of the integers between 100 and 200 that is divisible by 6. When it is 100 and 200 in between, we need to consider all those 3-digit numbers. The first 3-digit number will be 102, followed by 108, 114 till 198. As we have done it earlier, we need to find out the value of n, then Sn. In this sequence, we have the first term as 102, the common difference is 6, and nth term is 198. Let us use a plus n minus 1 into d as an. A value is 102 plus n minus 1 multiplied to 6, which is equal to 198. So when 102 is transposed to the right hand side, it becomes 96. So n value will be 96 by 6 plus 1. We get it as 17. So we need to find out the sum of first 17 terms, which is 17 by 2 multiplied to a plus an. A value is 102 and an value is 198. On adding this 102 with 198, it becomes 300. So 17 to be multiplied to 300 divided by 2. So 17 multiplied to 150. This will be 2515. Therefore, the sum of integers between 100 and 200 that are exactly divisible by 6 will be 2550. And the next question is question number 10. Find the number of terms of an arithmetic progression minus 12, minus 9, so on till positive 21. If 1 is added to each of the term of this AP, then find the sum of all the terms of AP thus formed. Let me do it in a phase wise. Here the given arithmetic progression is minus 12, minus 9, minus 6, so on till 21. So the first term here is negative 12. The common difference will be negative 9 minus of minus 12 becomes positive 3. Nth term is 21. So let us use an equal to a plus n minus 1 into d. On doing that, we can find the value of n. An is 21, which is equal to negative 12 plus n minus 1 into positive 3. So 33 by 3 will be the value of n minus 1. So n, you'll get it as 12. So the number of terms are 12. If 1 is added to each of the terms, we get minus 11 as the first term, minus 8 as the next term, minus 5 as the third term, and the last term would become 22. In this case, the first term is negative 12, last term is positive 22. Number of terms are same, 12 terms, and the common difference also will remain same. So with this information, we need to find out the sum of first 12 terms. So 12 by 2 multiplied to first term added to the last term will give sum of 12 terms. So 6 multiplied to 11. So 66 will be the sum of terms if 1 is added to each of the terms. Question number 11. How many terms of AP minus 6, 11 by 2, minus 5, so on, are needed to give the sum minus 25? Here, the first term is negative 6 and the common difference is the second term minus the first term. We get it as, here there is a mistake in the question, it's not printed properly, it's a negative minus 11 by 2. So negative minus 11 by 2 added to 6 will be 1 by 2. So the sum of n terms, we need to get it as minus 25 for which value of n. So let me make use of the formula Sn equal to n by 2 multiplied to 2a plus n minus 1 into d. Sn is minus 25 equal to n by 2 multiplied to 2a, which is 2 times of negative 6, plus n minus 1 into the common difference 1 by 2. When we cross multiply 2, we get negative 50 equal to n multiplied to negative 24 plus n minus 1 divided by 2. I have taken LCM. Once again, if you cross multiply, we get it as minus 100, which is equal to minus 24n plus n square minus n. So the quadratic equation so formed will be n square minus 25n plus 100 equal to 0. We can solve this very easily. 205 will be the numbers. So on multiplying 20 and 5 will be the number, minus 20 and minus 5 will be getting the result. So the value of n is 20 or 5. Here we got two answers because two values of n will be giving the same sum. Since a is negative and d is positive, the sum of 6 terms will be same as the sum of 20 terms. What really happens is all the negative numbers will be followed by the same positive numbers, so the sum becomes the same, minus 25. Question number 13, 12. S1, S2, S3 are the sum of n terms, 2n terms, 3n terms respectively. Prove that S3 is equal to 3 times of S2 minus S1. What is S1? S1 is n by 2 times of 2a plus n minus 1 into d. S2 will be, instead of n, I need to take now 2n by 2 times of 2a plus n minus n is again 2n minus 1 into d. So S3, here you observe I am taking 3n in the place of n. Now we have got S1, S2, S3. Now let me take the right hand side. I'll consider right hand side and I'll show that it is equal to the left hand side. So right hand side is 3 times of S2 minus S1. Let's do that. Substitute. 3 times 2n by 2 multiplied to 2a plus n 2n minus 1 into d minus n by 2 multiplied to 2a plus n minus 1 into d. Observe very carefully. There is n by 2 common. If I I'll not cancel this, I'll take n by 2 as common. I'll be getting 4a plus 4 times n multiplied to d minus 2 times of d minus 2a minus n times of d plus n times of n plus d. I have taken this minus and I have multiplied to each one of them. So I have got 3n by 2 multiplied to 2a plus 3n minus 1 into d, which is same as s3, which is equal to the left hand side. So I have proved right hand side equal to left hand side. Look at this question. This is the same question, we had solved it. I'll just tell you how to solve this. If you consider R1 and R2, R3 and so on as the radii of the semicircle so formed, and L1, L2 be the length of the circumferences of the circle so formed, the length of the circumference, say L1 is given by pi R1, L2 is given by pi R2. Pi R1 is pi times of 1 because they have given it as 1 centimeter, 2, 3 and so on. We get it as pi centimeter. Pi times of R2 is 2, so we get 2 pi centimeter. Similarly, L3 becomes 3 pi centimeter, and they have given that it is made up of 11 consecutive semicircles. So on continuation, L11 will become 11 pi centimeter. So total length of spiral will be the sum L1 plus L2 plus so on till L11. It is nothing but pi plus 2 pi plus so on till 11 times of pi. So pi can be taken common. We get 1 plus 2 plus so on till 11. Sum of 11 terms is n into n plus 1 by 2. So pi multiplied to 11 into 12 divided by 2. Divide by 2. So 66 pi will be the sum. If you want to convert this pi as 3.14, we get the result as 207.24. That's in centimeter. This will be the total length of the spiral. Look at this 14th question. The ratio of the sum of the first m and n terms of an arithmetic progression is m square by n square. Show that the ratio of mth and nth term will be 2m minus 1 is to 2n minus 1. So what is given? Given is sum of m terms to sum of n terms is m square by n square. I can make use of the formula. Sm is nothing but m by 2 multiplied to 2a plus m minus 1 into d divided by n by 2 multiplied to 2a plus n minus 1 into d equal to m square by n square. What you need to observe is in the denominator of both this numerator and denominator, these two that get cancelled. Left hand side m and one of the m on the right hand side, same way with the n, they get cancelled. So we'll be getting n times of 2a plus n minus 1 into d equal to m times of 2a plus n minus 1 into d. Let us further simplify. So 2an plus mn d minus nd minus nd will be equal to 2am plus mn d minus m times of d. You need to observe carefully. There is plus mnd on both the side. So let me cancel that out. What we get is 2an minus nd will be equal to 2am minus md. Let me take d term to one side. So m minus n multiplied to d will be equal to, here I can take 2a common, I'll be getting m minus n. So d value will become equal to 2a. Alright, now we need to find the ratio of the mth and nth term. Let us keep this result. We are going to use this. So mth term to nth term ratio will be a plus m minus 1 into d divided by a plus n minus 1 into d. Now in the place of d, let us take 2a. So a plus m minus 1 into 2a divided by a plus n minus 1 into 2a. Let us further simplify. A plus 2am minus 2a divided by a plus 2an minus 2a. So we get 2am minus a divided by 2an minus a. I can take a common. I'll be getting 2m minus 1 divided by, again a common, 2n minus 1. A get cancelled and the required ratio is 2m minus 1 is to 2n minus 1. Hence we have proved. Question number 15. Pth term means pth term is 1 by q. This implies a plus p minus 1 into d is 1 by q. Qth term is 1 by p, so aq. This implies a plus q minus 1 into d is 1 by p. These are the two equations. We need to solve these two equations to find a and d. A value and d value we need to find. If you subtract, you will be getting a cancelled. Let me give an answer. You will try this. You will get a value as 1 by pq and d value as 1 by p. With this information, we need to find the sum of pqth term. This will be pq by 2 multiplied to 2a plus n minus 1, that is pq minus 1 into d. On further simplification, we will be getting as pq by 2. I want you to try this. Since I'm running short of time, I'll be giving one more question. You can try that too. This is the question. I'll be giving you the answer. The answer of the sum of 5 terms is 5 is to the sum of 10 terms, we get it as 6 is to 17. I want you to try this. With this, I have completed arithmetic progressions revision. We shall start or begin with a new concept in the next session. Thank you.